Morning everyone. Welcome to our next session on ABAP learning series. So today we are going to discuss about the modularization techniques. So previously we have discussed how we can segregate different sections in an ABAP program. Today we are going to discuss how we can separate them, each part of the code, using different modularization techniques, and what are the benefits of this one is the code readability, understandability of the code, and it will divide programs into certain modules which can be simultaneously edited by different developers. Okay, so this is usually helpful when you are developing a large object and you need a team to develop that. Then you can divide our program or object into different modules, then you can assign it to different people. Okay, so let's open our SAP. Okay, so this is our old program, right? So let's not use this program, let's use this one. Okay, so this is the program. Based on the user input, it is giving us the results, right? Now, so here we are using only two tables, but instead of that, if we are working on a real-time project, then it will have multiple dependent tables work with and multiple formatting options of the data. Okay, so if you write this code like this, then the line of codes will be sequential. Okay, and if you need to find something, then you need to search line by line for the code. Okay, to overcome this, we are using different modularization techniques. Okay, so first thing we will learn about include programs. Okay, so these programs are non-executable programs, okay, which can have multiple executable lines of code, and these programs can be inserted into any of the above programs. Okay, so when these programs inserted into any above program, the executable lines of this include programs are part of the code of the inserted program. Okay, so let me explain this. Okay, double click on this one. Does not exist. Do you want to create the object? Yes, I wanted to create a include program. Okay, I have to give the package name, then assign the transport request over here. Okay, so this is it. So normally whenever you see an include program and there is a part underscore top in that program, then you understand that this is a top include which will have all the data declarations as well as selection screens and sometimes the initialization section of the program in this include. Okay, so now let's put it. Okay, so I have created this include and here I have done all the data declarations and everything. I just okay, so now save it and then I'm activating both the reports together. Okay, so here if you see there is an include program and this program has all the declarations and line of codes. Okay, so now if I execute this one, you can see the same things are already there, all the screen elements, everything, radio buttons, everything is already there in the include program. Okay, so that is why whenever you have inserted this include program in this report, and when you execute this report, you are getting the same text elements for that report. Okay, now go to text elements. So let's do one thing. Go to assign the same text elements as you have assigned there. Okay, I should not select. Where is the paste? Okay, there is no paste. Let's say, let's put it this way. We have to type everything manually. Okay, selection text. Okay, so now this top include will have your data declaration as well as the texts. Okay, so if you go there and see the text elements, there are no text elements. Okay, so we don't need those text element here because we have already created. So okay, now here in this include program, if you go to the okay, so in this case, if you see the text elements, you are in the top include, but when you go to the text elements, you are going to the text element of the main program. Okay, not of the include program. So whatever texts are maintained, those are dependent on the main programs. So you cannot carry the text or text symbol or text selection text in your include program. Okay, so now execute this one. You can see the selection screen is already there. Okay, so now the next modularization technique is, let's create one more program. Okay, include ZBC405 report 6 underscore F01. Okay, so you can give any naming convention. There is no hard and fast rule that your include program should be of the same name as of this one. Okay, I am just creating this based on the understanding. Okay, so when it comes to the naming of the programs or anything, it is actually dependent on your project guidelines. Okay, how the program names and how the include programs name or report program name should be, as well as when you are creating a table, data element, domains, all the naming should be followed based on your project documentation. Okay, so now, so is this include, it has all the declarations. Okay, let's put all the codings in this declarations, the second include program. Okay, so I am creating this include program, same package and a transport request. Okay, now activate this. So this is your main program and this is your to include programs. One it has data declaration, one it has the executable codes. Now execute this one. Okay, execute. So you can see the output generated without any issues or without any error. Okay, and the results are same. So this is one technique where you can create include programs, okay, to modularize the different sections of code. Now let's see one more section. Okay, so let's comment this one. Okay, now so here if we write the codes line by line and there are 300 lines of code, it is very difficult to maintain those codes. Okay, but if you modularize these codes, it is easy to find. How? Case gc underscore mark. Okay, when p underscore all p underscore net int. Okay, now let's create three different subroutines. Okay, now perform or using so can have oh, no. So this is normally called a subroutine. Okay, so this is the subroutine name and these are the parameters. Okay, and using that means this subroutine will use the values under so underscore char or so underscore con or so underscore fdd, and it will change the value of lt underscore flight. Okay, so now let's double click on this. Does not exist, so this subroutine does not exist. It is asking you whether you can create or not. Okay, click on yes. So now select this is your report, select this report. Okay, so you can see below the program this subroutine has been created, right? So now copy this part of code because in the subroutine we want to use the subroutine to perform the same task whatever it is performing under p underscore all, right? That means it will select all the flights based on the input criteria. Okay, so now let's format the code so it will look good. And if you see, this subroutine does not have the so underscore char. Okay, so you have to use these values. And if you see, this lt flight is the changing parameter. Okay, and after the subroutine is being created, this parameter has been changed to p underscore lt underscore flight, right? So copy from here and paste. Okay, so your subroutine is ready. But if you see, these parameters and these parameters have a different name. Okay, so when you are calling the perform statement, these parameters are called as formal parameters. Okay, and these are called as actual parameters. So if you go into details, then it will take long. Okay, so you understand. So what is the use of using and what is the use of changing? Okay, so similarly we will create other subroutines. Okay, subroutine for national flights and subroutine for international flights. Okay, same way, double click on this subroutine name, select the program and write the necessary select statement. And this is a national flight. Okay, so we need to mention this. Okay, so if you see this program, okay, we have commented the coding include, so let it be commented. Then initialization, then in startup selection we have created 3 subroutines. Okay, and we have assigned everything. Now end of selection. Okay, perform output. Okay, so this is our output internal table. So I have created this subroutine using this internal table. Okay, I am not changing anything after that, so I don't need to use any changing parameter. Okay, now create it, select the main program. Yes, and this GS flight is in our top include. Okay, so this variable is global to this report, so you can access directly to this structure. Okay, now save this one and activate it. So here, as you can see, we have created subroutines: perform get all, get national flights, get international flights. Okay, and in end of selection we have perform output using LT flight, because this is the output internal table, right? So if you scroll down below, these are the codings related to the respective subroutines. Okay, so now if you see this program, okay, it has initialization and it has startup selection, and these are like code snippets. Okay, and then instead of end of selections, instead of this loop, we are writing as perform output. So this kind of coding is more understandable than this, right? So now let's uncomment this one. So already the code is there, right? So let's put our programming logic in this include. Okay, so our programming is logic is till end of selection, right? Now cut these codes and paste it over here. Okay, now save this one, go back. Now all these are subroutines are related here, right? So let's put all those subroutines into a different include probe, right? So create this include. Okay, now put all the subroutines in this include. Okay, go back. So your main program has three includes. One is the top include, which have data declaration. Second one is the program logic, which has the logics, and third one contains all the subroutines that you have created. Okay, so the include which contains only the subroutines, that include is called as subroutine pool. Okay, now do the pretty printer and now check activate. So I am activating main program with all the includes. Okay, now you execute your code, select all flights, You are getting the flights domestic as well as international. Now select the domestic flight, execute. You see all the flights are domestic, and if you select the international, execute, all the flights are, you can see the country is Denmark, the country is US, the country is US, the country, two country is Denmark. So all the international flights being selected. Okay, but when you come to your program, you see your program is very sorted with minimum lines of code. Okay, so if anyone just want to see the declaration part, he can go to this include and he can see all the declarations or selection screen how you have made. If someone wants to understand the flow of the program, then he can just go to this. Okay, this is the initialization part, this is the startup selection, how the different entries are being selected, and at the end of selection how the output is happening, right? If someone want to understand inside it how everything is certain, he can directly double click get underscore international flights, and he can see the respective logic of the subroutine. Okay, else if someone wants to check how many subroutines are there, what are all the subroutines, he can directly go to the subroutine fields. Okay, so here you can see all the subroutines related to this program. So in today's session, we have seen how to modularize a program using include programs as well as subroutines. Okay, so in our next session, we will see few more additional topics related to this modularization techniques. Okay, and in tomorrow's session, if you see this codes, okay, if you see this code, we have this bracket symbols with related to select options, right? And here also we have created some different types r underscore char con like that. So in next session we will see what is the difference between parameter and select options, and how you can give different things in the parameter of the subroutine, and we will also see the external subroutine. Okay, till then take care, bye bye, see you.